All right, so hello, Mr. Naylor. My name is Stephen Welch. I'm an undergraduate student at UNC Charlotte with the Electrical Engineering Department, and I'd like to present to you a senior project proposal. I know you're very, very busy, but if I could just have a moment of your time just to even listen to this and just some feedback, I'd be really, really appreciative of it. So I do appreciate it. Thank you so much, sir. I'd like to start with the top poster here. The top poster here is based off of these questions, Heilmeyer's Catechism, which are kind of like Heilmeyer's dogma. And it's really, really good questions, and I thought it'd be a really good way to kind of start the proposal. And so the first question is, what are you trying to do? And so for me, the whole kind of impetus for this whole project was to improve car safety and just reduce the overall number of accidents. And I know that's a project now, even currently with the DOT, North Carolina Vision Zero. I want to make car technology more widespread, and I want to come back to this point again because I think it's really important, especially with the technology we have nowadays. And I also want to just improve road travel safety. So I just want to prevent more fatal accidents and just make it safer and make it more enjoyable for everyone to drive. And that's really what I'm trying to do. And so really, how's it done today? Well, I want to say this before I say anything else. I'm not against anything how it's done today. I actually think it's really good. I think that the current system we have nowadays has saved many, many lives, and it's very important. And I don't want to get rid of it in any way. And in fact, there's some things, again, this kind of universality of it, I think is really important. But the current way we do things now would be with a stoplight or a stop sign. And the two biggest kind of limitations that we have with this so far is that the driver must see, but then also obey the traffic sign or signal. And sometimes that happens accidentally. Sometimes someone is maybe looking at a radio, or they drop their keys and they suddenly look down and they don't see the stop line or stop sign, or they don't see the sign at all. But then the other part of it is the obey part of it, and we have to make sure that people are obeying the traffic signals as well too. That's usually done through kind of law enforcement, but then technology-wise, just staying in that same kind of vein, which is the red light camera. Now, the red light camera was meant to discourage red light runners. I think it's a really good piece of technology. The limitation that I have with it is that it has the effect of taking the picture after the event happens, and I want to try and be less reactive and more kind of proactive in preventing it altogether. And then, of course, the kind of ultimate technology is the self-driving car, and this is supposed to kind of solve everything. This is supposed to be the kind of golden ticket to everything. But in this sense, the car makes all the driving decisions, but there are some kind of limitations as well too, which is that it's very expensive technology, it's very new, and it's limited in scope. And this is important to me because when I think about vehicles on the road, it's not just a self-driving vehicle. There are other vehicles as well too. There are other dump trucks, garbage trucks, utility vehicles, Mack trucks. There are so many makes and models, so many different years, so many different brands. So I think in this sense that even if one person is driving a self-driving car, they're surrounded by thousands of people who aren't. So I think that's that kind of limited in scope, and I think that's the beauty of things like stoplights and stop sign, which is that you're universal. Is that it doesn't matter what vehicle you're driving, a stoplight is a stoplight is a stoplight. And so I want to kind of take the limitations, but also take the benefits of what we're currently using and try and bring it into something new. So I want to kind of talk about what is new in my approach, and in this sense, I really wanted to touch on how the road and car can kind of talk to one another. So changing the way that we view the road itself. And I really do believe that the car can be more of an assistance. So the car is not making all the decisions, but the car is assisting in those decisions as well. And I think importantly too, this is another thing that would change, is that the signs are no longer a suggestion, but really a command. That the signs are really something that the car must follow. And I'll talk a lot more about that in the bottom part of it here, how that technology would work more in a real setting, but that's kind of where I want to kind of change in my approach, which is that this road-car kind of synergy, but then also making signs, something that you must see but also obey. And then if you don't see them, well, the car sees them, so to speak. What impact will it have? Well, again, the whole kind of point of this project was just to reduce traffic-related fatalities. I want to make it so more people make it home. I want it to be safer for people. I also want to reduce the cost for insurance and medical bills and crashes. The cost to the North Carolina taxpayer bill is very high, even just accidents in general. So I want to kind of reduce that as well. And then I just want to help new drivers as well too. There are people who are new to the road, they're not really kind of sure what decisions to make. And I think the car can kind of assist and help them make better, safer decisions as well. All right, so what are some of the challenges with doing something like this? Well, especially with this kind of technology, you want to improve against hacking, and there are some benefits to using this technology. I'll talk about a little bit of the XB, which is that it's not an IoT device, it's more like a kind of mesh network device. And in fact, the one I'm using here is Series 1 XB, which is more like a handshake device, so it just talks to other devices. It's not connected to the World Wide Web. But again, even with that wireless technology, we still want to make sure it's safe and secure. Of course, with kind of any engineering, we also want to make sure there's plenty of stability and plenty of backup. So when we introduce this system to like a vehicle per se, this would be the accelerator and brake, and I'll talk about this a little bit more as well, but you want to make sure that even the worst case scenario, that these are not damaged, or that even in the worst cases of scenarios that the driver would be safe. So, and then I think with any technology, it's something that we sometimes overlook, but public trust. I mean, getting the public educated about the technology, but also gaining their trust about it. This is the technology they will use. So we want to make sure we do a good job of helping to kind of educate and gain that trust. So, all right, so what are some of the costs? Well, the cost will be on our side for the education, the labor, and the research. And I think the students and the university, I think we can provide that. I mean, I think it's a benefit to the students because they gain that experience, and I think it's a benefit to the university because it brings more interest and more kind of investment in the university. Two things that I'm not as knowledgeable about, but I'd love to consult more with the civil engineering side of it as well, is the cost of construction and the cost of upkeep. So, finding the most cost-effective and efficient way to install these systems, but also to upkeep and maintain those systems as well too. And then finally, the summary. For me, it's kind of there's a book by Stephen Covey called The Habits of Highly Effective People, 7 Habits of Highly Effective People, and he mentions this kind of philosophy in there called a paradigm shift, and I really like it because to me it changes the way that we view the road, which is the paradigm shift is the road is no longer this kind of just rock, it's no longer this kind of just inactive object, but it's actually quite proactive. It's something that's actually active in the decision-making process and very helpful as well too. So I actually think that would be a really good way to kind of change the way you view it. We create that kind of road and car synergy, and then I think last but not least is, if it takes off, if the technology really works and people are interested in it, you create a kind of a road revolution. You create this kind of new way of viewing things, and I don't think that's impossible either. I mean, you look at something like the Wright brothers in North Carolina, where they were trying something new, and people might have looked at that and said, what is that going to do? What do you mean you just flew 20 feet, or something like that? And I think when you look back at that and look at the way that flying technology has helped just transform the world, I think that's really where you could kind of view this system, taking place in the future, and I don't think that's an impossible way to view it. So you'd always have to kind of start out small, but then you never know where it goes from there. So, but that's kind of a general overview through Heilmeyer's Catechism. And then I want to talk a little bit more about actually the technology itself. So I created a little model here to kind of demonstrate the technology. Now this won't be the exact technology that we use in the senior project itself, but a lot of the pieces of it, the components of it, will be used. So the Arduino, the XB, the kind of 3D print, I'll talk a little bit more about that. A more expanded version of it. This is still just a model of it. And again, this will be a model of a car, but we'll kind of move on to bigger models as well too, but I'll talk about that a little bit more in the last part of it, the phases of it. But I just want to give just kind of a demonstration of really what I'm trying to hit at here, what I'm trying to get at, which is the kind of different scenarios that you might find yourself using this technology. So this technology here would be something that you can install in a intersection and at a stoplight. And that was one thing I was talking about a little bit earlier, is the stoplight stop sign. So I want to give you two scenarios, and hopefully this will kind of visually demonstrate a little bit better, you know, what I'm trying to say around this. But let's say you have a car on the road, and let's say the car suddenly sees a stop sign. So what the technology is going to do is it's going to hit the brake of the car, and then it's going to go back to a kind of a normal speed. So I'll show that one more time. It's going to stop, and it's going to tell the car stop light is active. Stop the car, prevent it from running the red light, and make things much safer. That's kind of one scenario. And let's say the car is kind of driving up the street, it's going along. Let's say there's a problem with the speed limit. Let's say it gets to a speed limit, it's going 50 miles an hour, and it's like, that's too fast. So it's going 50 miles an hour at 35, it's really dangerous, this is a community area. Let's say the person pressed the accelerator. The device is going to tell the car, look, your speed is 65 right now, but the speed limit is 35, let's say, you're going way too fast, you need to slow down. And it's going to tell the car, hey, you need to slow down. And it'll slow the car down again and kind of prevent it from, you know, moving even kind of further. Prevent it from moving kind of too quick. So I'll demonstrate that one more time as well. So let's say it's really speeding up, it's going way too fast. You know, it's going at 65 and at 35. Again, the LCD screen here, this would be something we could install in a vehicle. We'll talk a little bit about it here as well. But this kind of LCD screen in a vehicle could kind of tell the car, hey, going way too fast, way too fast. And then the system in the car itself would depress the brake and kind of press up the accelerator, kind of slow it down and get it going back to a normal speed again. And so those are kind of just two scenarios, but there's many more options for it as well too. But the technology itself is, what these are working off of will be in more of a real-life setting. Now these are servo motors, but in a real-life setting, we might have linear actuators that a linear actuator could kind of press down or press up against the brake to kind of decelerate it. And these could be powered by even just the 12-volt battery in the car itself. How this is working is through a wireless communication. So in the road, what I would hope to have is some kind of device here that we can install on the road, and that this would sit in the road or sit in the asphalt itself and kind of sit flush against the road. And in this cavity here, we could put a XB device, we could put an Arduino in here, and let's say, for example, with the speed limit scenario, you might have this device remotely installed somewhere. Well, what we could do is we could take the kind of flower petals and expand them outward and install maybe solar panels on there. And so that this remote kind of device could be sitting in the road here in like a 35-mile-per-hour neighborhood. And we could put the Arduino in a program and say, hey, any car that passes over with this system, let the car know that this is a 35-mile-per-hour zone. And so a car with this kind of system installed in it would say, it would be driving over the flower in the road, pick it up, and go, wait a second, you're going 65, this is a 35-mile-per-hour zone. That's what the speed limit is telling me, or the speed sign is telling me. You need to slow down. And therefore, it would use these kind of actuators and use the system installed in the car And the system itself would also have an XB. I know it's hard to see XB installed here as well. And so I'm going to have this system talk with the XB installed in the road, and that would kind of slow the vehicle down. And there's many other uses for this as well too. One of them would be a school zone. So you might have a timed school zone where the school zone says, from 8 a.m. to 9 a.m., the speed limit's no longer 35, it's 20, it's 15. We can actually make that. You could program it into the Arduino in the road. And so you might have a vehicle driving over in a school zone. The flower says, oh, by the way, this is telling your car, hey, we're in a school zone now, you gotta slow down. Actually, it's only 50 miles per hour as opposed to the regular 35. So that's another possibility. One other interesting thing is not only the cross section, but for like a T intersection, you could actually be kind of predictive with this technology. So you might have this technology sitting here at a stop sign, for example. And if there's a road coming along here, maybe there's like a hill that no one can see along, or maybe that road is really quick, a lot of people come by really quick. You could have this technology installed at the stop sign. You could have a technology installed a little bit further down the road. Maybe you have the technology installed behind a hill or something like that. That technology could pick up a car, tell it to this flower and say, hey, by the way, I just noticed a car is coming down here. Don't go, don't turn out, don't turn in front of the car. And so you could actually almost kind of predict an accident before it happens and prevent it at the same time. You could actually have the vehicle, the driver tries to go, why did it stop? And it goes, oh, by the way, there's someone coming, and he goes, what? Looks, prevents the accident from happening altogether as well too. That would be more of a T intersection kind of a scenario, not a cross one, but even the cross one works out as well too, just because of the preventing any kind of accident in that intersection. So and this would be a complete system. So you would have the flower installed in the road, and these would have the solar panels attached to it on the outside here. We would have the Arduino and XB installed inside the cavity, and then we would have just a cap to it to prevent any kind of dirt or grime from getting in there. This cap could be used for a lot of different things as well too. It could even be used to kind of enhance the signal. And this is something we're going to learn more a little bit about with when we take our waves class this semester, which is that how can we enhance this wireless signal coming out? And so as another possible use of it. This wouldn't be real size though, it's just again kind of a model to it. That would be one part of the system. The other part of the system would be the system installed so that the driver can see what's going on and actually see through an LCD screen what's going on. Why am I slowing down, or why is it stopped? Oh, there's a stop sign, or oh, the speed limit here is such and such. That can inform the driver. And then the last part of the system would be the system installed on the brakes and accelerator to kind of decelerate or prevent the vehicle from doing something not good. So that's kind of where the system itself kind of runs into play. And then the last, but certainly not least, would be I call them the kind of phases of it. So it's a good kind of segue from here, because how am I going to kind of implement this? How am I going to actually put this in the real world? So for me, when I look, I kind of break it up into 5 phases and then beyond. So what I'm looking at for Senior Design 1 and the Senior Design 2, Senior Design 1 would be maybe utilizing not a little miniature car, but actually like a children's car. So like a car for like younger children, maybe like 5 or 6 years old, that have like the just single pedal. And we could modify that. We could have a mechanical engineer on the team telling us, hey, here's how I think you could implement this system. Let's test it out with the children's car. And it's a low-cost kind of risk. It's a children's car. You don't have to worry if we don't get it right the first time. It's like, well, it's not a huge risk to, we're not actually modifying a real car. We could use a civil engineer to kind of help us talk about, how would we kind of make this? What material? How is this going to affect the road when the asphalt is maybe, expanding, contracting? what should we worry about installing in the road. Any environmental concerns as well too. We don't want to pollute anything as well too. We want to make sure it's done safe. We want to use material that are safe for the environment as well. So we could consult with a civil engineer. We could even talk more with a mechanical and electrical engineer to kind of make a little stoplight as well too. We can make something on there, so again, something kind of miniature, but something where you can kind of demonstrate the, I call it like just a proof of concept, just, hey, does this actually kind of work in a bigger setting? And that to me would be phase one. That could be senior design 1. And then senior design 2, we could kind of expand it. And in the university, you see all kinds of people. I would see a lot of people driving around in club cars, these little kind of golf carts, I guess I would call them, or I think some of them are like Kawasaki mules. I have to think that there might be some extra ones, maybe not in use anymore, or maybe that we could actually use, and we would modify them, not permanently modify them, but we could modify them, again, taking the advice from the team, so we could take the advice from the mechanical engineer, the civil engineer, the electrical engineers as well on the team, and actually say, all right, well, how can we kind of expand this and make this even bigger? This is an even bigger kind of proof of concept, like, hey, here's a vehicle that has a human, that can actually drive it. Here's the response, and we can get some data as well too to kind of say, oh, maybe we need a bigger surface area, or maybe we need a better kind of device installed in the vehicle. It needs more pressure. We didn't get enough with the linear actuator. We need something with more force to it, and so we can kind of learn from that. We might get a better idea of how this system would work. Someone's looking. Do they get a good view, or do we have to raise up the view, or do we have to maybe put like a shade over it? All these kind of different data that we can gather from the project. And if it works, I would love to expand even more. So phase 3 would be more with a fleet vehicle. Now this might be something that the university lets us use, again, not permanently modify it, but we can modify it and actually do more of a full-scale testing, but in a limited scope. So only in the UNCC campus and only in a designated parking lot, so it's safe, for everyone involved. But we could actually expand that even further, and we could look at things like how to install the system in an actual road. Again, more consultation with the civil engineering student, team member, and the department, and we could just get all that information to kind of, make our case even stronger into phase 4 and 5. The phase 4 would be a fleet vehicle, but a larger scope. So we might actually go out to I always think of the intersection with the new bridge is installed. That big intersection there where they're putting, I think, the new health center as well, health and recreation center. We could try the system there. We could find another intersection to install it, and test it out actually in a bigger kind of scope, and give even more kind of data, more kind of information, more kind of proof that, hey, I actually think this would work in a much larger scope. And then phase 5 and beyond, to me, is more real-world testing on the road, but then more implementation. And to me, this is always a good, exciting thing about this, that this could be a project that really incorporates the whole university in a lot of ways, because implementation is not just engineering anymore, it's business. We can consult with the business department, and they can say, hey, this would be a good project. We could utilize this through the 49er Foundry and Portal. We could speak with the graphic design department. They could make a logo for this. This is not a very pretty 3D print, or not a very pretty logo, but we could actually get them to really design and utilize it and help us with the marketing of it. I mean, this is something that we could help, and through the North Carolina Department of Transportation as well too. We could just get everything together into a really nice big project, and then we could also even go out to local community colleges as well too, and talk about to them, what are some of your concerns about installing a device like this in the car? If we give these kind of incentives, how could you install this device? What could you do with that? So I think that's something we'll have to look into. Also, the legal side of things, talking again in consultation with the North Carolina Department of Transportation, how do we make this a real world thing? So to me, it's really exciting to think about that again, you kind of start out really minor, really kind of small model scale. You work your way up. gain more trust, you get more kind of information, and something that might be something you do in the real world. And the last thing I'd like to talk about, which is the kind of benefits, and the name of this project, I call it Fern Road. And a fern is really interesting because when you look at a fern, the more you look into it, it just keeps repeating itself. So you look at a fern and it repeats, you look at this part and it repeats, and it's essentially just always kind of growing outward. And if you look at something like Google Maps and you look at all the little different roads connected everywhere, that kind of evoked an image to me of this kind of like living plant, you know, that it's kind of connected everywhere, that the road is a part of everything else. And I thought to myself, that's also kind of what I think, you know, the North Carolina Vision Zero is talking about. They call it the 5 E's. The 5 E's are engineering, education, enforcement, emergency response, and everyone. And I think that's nice because, especially with the Fern is really saying that this is a project that might start out as a little small project for engineering, but this project affects everyone. It's going to kind of branch out like a fern into the community. It's going to help the community with investment. It's going to help the university with more interest in research investment. It's going to help, I think, with jobs as well too. I think that we could actually, you know, create a kind of industry that manufactures these, you know, small business, and kind of work your way up. I think it would affect the North Carolina Department of Transportation in a big way. I think it would touch the lives of everyone too. I think you're going to have a lot more people coming home. You know, there's going to be a lot less accidents, and I hope, you know, again, as Vision Zero says, I hope that there's zero. I hope we get to a point where we go a year without any accidents or any fatal accidents at all. I mean, that would be an amazing thing. I mean, to me, that's where it all started. This is why it all, you know, wanted to do that. And so I think in that way, that's what the Fern really kind of represents, is that you start out small, but it really kind of connects and branches off and touches the lives of everyone in a really important and good way. So I want to conclude. I want to thank you again for your time. I know you're very, very busy. I want to thank you again, Tris, for listening to me talk about this. I'm really excited to share this. I'm really excited to talk more about it. And you know, I would love to speak with you more at your earliest convenience. I would love to hear, you know, any input or feedback you have, any questions or comments. I do apologize. I know it is really hard to see these. I attach these in the email as well too, so that it's easier to see. I'm sorry just for the lighting, everything. I'm doing this in my apartment, so I'm trying to make the best of it. So I do apologize. I know it's hard to see. I'll try to take just some more pictures, just information about this, so it's kind of easier to see what's going on. And yeah, I would love to just speak more with you at your earliest convenience. And I would like to end with a quote, if that's okay. This is a quote by Herbert Hoover. Now, Herbert Hoover was the 31st President of the United States. And a lot of people know this. He was a mining engineer before he became president. And he was interviewed by a magazine on what it meant to be an engineer. And I think he summed it up quite well. I think for me, it's like that's what I think about when I think about, you know, why I became, you know, was interested in becoming an engineer. So I quote, "It is a great profession. There is the fascination of watching a figment of the imagination emerge through the aid of science to a plan on paper. Then it moves to realization in stone or metal or energy. Then it brings jobs and homes to men. Then it elevates the standards of living and adds to the comforts of life. That is the engineer's high privilege." Thank you again for your time. I do appreciate it.